streamed live or not. So looks like I'm ready and looks like we are live on YouTube as well. Mm, yeah, great. So the agenda once more today is that we are going to go through uh, one more problem on one problem just on maxima and minima of functions of multiple variables, and following that we will solve a few problems on. Is anyone saying something? No? Okay. So let's take the function. Let's look at a function. Uh, let's take a function, for example, a very simple function we'll take, right? Let us take this particular function, the examine examine the maxima and minima, the extreme values of f x comma y is equal to, uh, let's have a look at it, x to the power 4 plus y to the power 4 minus 2x square plus 4xy minus 2y square. All right. So this is the function that we are going to examine the extreme values of, right? So again, as you see that this function has got two variables, right? So there are two variables, x and y. And if you really plot this function, we'll need a z-axis as well. So the plotting of this function would look something like this, right? You'll have a z-axis, you'll have an x-axis and a y-axis. X-axis, y-axis, and a z-axis. So it will look more like a surface somehow, right? I'm not that great at drawing surfaces, but it would look something like a surface. Now we would want to know, where this function reaches the maximum value, where the function reaches the minimum value, or whether there is a saddle point, or whether there is a point of inflection, and so on. Okay. Now, in order to identify these points, we have to follow an algorithm. And in this algorithm, in this working rule, we got to understand a few things. So first of all, let's write down the algorithm to solve this kind of problems, right? And then we'll come back and solve this problem. So given f of x comma y, right? F of x comma y, right? What we do is we find out the first partial derivatives. The first partial derivative fx. Fx is the partial derivative of f with respect to x, considering y as a constant. Fy is the other first order partial derivative, that is tau f by tau y. Here we consider y as the variable and x as the constant. Now, once we get these two partial derivatives, what we do is that we get a system of equations. So, what we do is that we solve the system of equations in which the first equation is fx equal to 0, the second equation is fy equal to 0, right? So, we got the first equation as fx equal to 0, the second equation as fy is equal to 0. So there are two equations that we have. We'll now solve these equations and we'll find out certain values of x and y. Okay. Now you see, when we find out these values of x and y, what happens is that we identify the we identify a certain, like extreme points. Like for example, we'll get x1 comma y1, right? Or x2 comma y2, and so on. There might be 2, there might be 4, there might be 5, and so on. So these points are called the extreme points, right? These are called the extreme points. So we identify the extreme points of this particular uh, graph, right? F of xy of this function. So that is the first. That's the first job. The first job again, we find out the partial first order partial derivatives, and we identify the extreme points. The second job is a little. It's a little tricky. What we do in the second step is that you know the f of x comma y is f of x comma y is there. From here, we find out three different derivatives, right? So from here, we'll find out the second order partial derivatives, second order partial derivatives. And the second order partial derivatives are as follows. So the first second order partial derivative is called R. So R is tau square f by tau x square. How to find out that? It is very easy. You already have tau f by tau x, right? Tau f by tau x. So you differentiate partially tau f by tau x with respect to x, keeping y as a constant, right? So that is the second order derivative. So like this can be written as a shorthand as fxx, by the way. Hmm? Okay. Once we are done with this, we proceed to find out the next second order partial derivative, that is tau square f by tau x tau y, right? And there are two methods of doing this. But since we already have tau f by tau x, right? We can just do tau by tau y of tau f by tau x. Correct? So the term inside the bracket is already there. We have already calculated this, right? So what we do is that we once differentiate this tau f by tau x with respect to x, and we get r with respect to y, and we get s. That is how we get fxy. Correct? This is the second order partial derivative. And the last second order partial derivative that we have to find differentiate by using the differentiation method is tau square f by tau y square. The method to do it is we already have tau f by tau y, right? We shall differentiate this partially with respect to y, keeping the x as constant. So this will give us the final third or second order partial derivative fyy. Correct? So we have found out what r is, what s is, and what t is. Okay. Now, once we have done that, we have found out these values. What we'll do is that find we will find r, s, t at each each of the extreme points, right? At each of these extreme points, you remember x1, x2, x1, y1, x2, y2. These are the extreme points. See, we got the extreme points by solving fx equal to 0 and fy equal to 0. So at each of these extreme points, we'll find out what our ST values are. Now, once we find out what these RST values are, we are going to find out, like what is the value of RT minus S square, right? So that is the value we are going to find out. For example, so you remember when we are solving quadratic equations, we find out the discriminant, right? So similarly, here as well, we are going to find out this value. Now, this particular value might either be less than 0 or it can be greater than 0. So, if this value is less than 0, we'll have a different like analysis altogether, right? If this value again is equal to 0, we will say something about this extreme point, at which the value is equal to 0. And if this value is greater than, oops, and if this value is actually greater than 0, then we will have a few more analysis to do in order to identify what kind of extreme point we are dealing with. Okay, so first of all, let's consider when this RT minus S square is greater than 0. When RT minus S square is greater than 0, the last case, what we do is that we divide this particular case into two subparts. Okay, the first and the second subparts are based on the values when we will see whether the value r is greater than 0 or the value r is less than 0. Again, what is r? R is dou square f by dou x square. That is r, fxx. Correct? This is r over here. Huh? So we are going to identify what happens when r is less than 0 and r is greater than 0. Now, again, this flowchart is extremely important. Now, if we have r less than 0, we will say that we have reached maximum. Okay. If we have r greater than 0, we will say we have reached minimum. Right? Okay. Then, this is the case where we are considering that. Okay, I'm not audible throughout, or just now I'm. Uh, Okay, let me just try to uh, unmute and mute myself. Okay, give me a second. Maybe I'll change my microphone. Yeah, uh, it's fine now, right? Better, better. But my screen is not visible. Okay, all right. I'll try to run that again. Mhm. Mm. The screen was not visible at all throughout, or just now it went well. Okay, okay, okay. Yeah, I think now it should be visible again. Can you please confirm whether it is visible or not? Okay, okay, great. Cool. So what we're doing is that we are identifying various methods, various tests to see to check whether an extreme point is maximum or minimum, or whether there is a saddle point, or whether we need some other methods to identify whether identify other methods to find out, examine the um, the type of the extreme point, right? So what we did is that we found out what is the second order derivative, r, s, and t. R is the second order derivative both with respect to x, keeping y as constants. S is the partial derivative, the second order partial derivative with x as a constant one time, and y as a constant in the other time. And t is the second order partial derivative, taking x as a constant and y as a variable both the times of the differentiation. And we had identified some extreme points. At each of the extreme points, we are finding out the numerical values of r, s, and t. Right? You'll get those numbers over there. They can be positive, negative, decimal, whatever. You'll get some numbers for r, s, and t. Now, we'll find out RT minus S square, correct? This value again will be a number. It would be either less than 0 or equal to 0 or greater than 0. Let's say that RT minus S square is greater than 0 at a particular extreme point. Then we will try to find out whether r is greater than 0 or less than 0. If r happens to be less than 0, then the extreme point that we are dealing with is a maximum extreme point. If the r value is greater than 0, mind it that rt minus s square is greater than 0. When these two conditions are satisfied, the given point, the extreme point that we are dealing with, is a minimum point. Okay. Now, the other case is when the rt minus s square is less than 0. So in this case, what we reach is a saddle point, S-A-D-D-L-E, saddle point. We reach a particular point called the saddle point. And if rt minus s squared is equal to 0, we have no idea whatsoever about what this point is like. Okay, we need some further tests, which is beyond the scope of our syllabus right now. We will like deal with it later in higher semesters maybe. Okay, so having said all of this, let's try to solve the problem that we have in hand, right? So the problem that we were trying to solve little while back was as follows, right? Um, oops. Okay. Uh, a lot of technical glitch happening in this session, but we'll sail through that. Okay, so this was the problem. We are examining the extreme values of fxy is equal to x to the power 4 plus y to the power 4 minus 2x square plus 4xy minus 2y square. So let's try to solve this problem. Okay, so let's write that down. So fxy is equal to x to the power 4 plus y to the power 4 minus 2x square plus 4xy minus 2y square. A very nice symmetric function is at hand right now. So the first job is to find out fx. If the variable is x, the variable is x, right? And the constant is y. So dou by dou x of x to the power 4 minus dou by dou x plus dou by dou x of y to the power 4 minus dou by dou x of x twice x squared plus dou by dou x of 4xy minus dou by dou x of 2y squared. This is what you get. Is no y here, so there is no constant term here. So this will become 4x cubed plus this is a 0 because y is a constant with respect to x, minus this would be 4x because 2 comes outside, x squared becomes twice x, there's a minus in front and it becomes 4x, plus 4y is a constant and dou by dou x of x would be 1, right? So it is 4x, and then finally the last term is minus 0, right? So if we write that down in a very nice way, we get 4x cubed minus 4x plus 4y. That is fx. That is the first derivative of f with respect to x. Further, we have to find out what fy is, right? Okay, okay. Hmm. Okay. Next, we'll find out what fy is. Fy is dou f by dou y, right? So, so this is equal to dou by dou y of x to the power 4 plus dou by dou y of y to the power 4 minus dou by dou y of 2x squared plus dou by dou y of 4xy minus terms one by one, and hence we'll be getting the complete partial derivative. Now here, when we are finding out dou by dou y, you see that x is a constant. So the first term here vanishes. Plus dou by dou y of y to the power 4, there is no x or any constant here. So it will be a normal differentiation for y cube minus again here there is no y at all. So this is a full entirely a constant term plus 4x is a constant. We'll take out that from the differentiation, and the partial derivative of y with respect to y is 1. So 4x multiplied by 1, that's 4x minus here 2 will come outside, and the differentiation of y squared is 2y. So this will become 4y. Okay, now let's clean this up a little bit. 4y cube minus 4x plus 4x, sorry, minus 4y. So this is exactly what we have got, right? So we have got fx as something, fy as something, and now we need to um, solve the system of equations for solve the system solve the system solve we need to solve the system 4x cube minus 4x plus 4y is equal to 0, which is equation number 1, right? And 4y cube plus 4x minus 4y is equal to 0, which is the equation number 2, right? Now we just need to solve these two equations. Okay. Now let's try to solve these two equations, right? When we solve these two equations, we'll get some values of x and y, and we try to find out what are the extreme points, right? So the aim here is to find out the extreme points. Find the extreme points. The extreme points are the points where the maxima and the minima are there, right? Okay. Now, let's let's try to add these two equations. Correct. If we add these two equations, we'll get adding again. You see, the solving system of linear equations is different for different systems. In this system, the reason I'm adding is as follows. 4x cube minus 4x plus 4 is equal to 4y equal to 0, and 4y cube plus 4x minus 4y is equal to 0. The reason why I'm adding these two is because you see very nicely, in a very colorful way, these two get cancelled out. So what we are left out with is as follows. We get 4 times x, maybe, yeah, 4 times x cube plus 4 times y cube is equal to 0. So from here, we can write 4 and then x cube plus y cube equals 0. And if you remember this identity from school, I'll try to write down the identity. It says that if a cube plus b cube is there, then we can write this as a product of a plus b multiplied by a square minus ab plus b square, right? So using this identity, we can write this as follows. 4 times x plus y times x square minus xy plus y squared is equal to 0. Correct? And of course, 4 cannot be equal to 0. So x plus y multiply x square minus xy plus y squared is equal to 0. Okay. Now, we need to solve this equation. We need to find out the values of x and y. Uh, let's now, right, the easier one term over here, easier one is factor here is x plus y. So this gives us y the expression x cube plus y cube will be equal to 0. Correct? So what we would require to do now is we would want to like substitute this value y equal to negative x in let's say the first equation, right? And from there we'll get some values of y. Okay, so screen is not visible. It is visible. Okay, great. Okay, so I don't know what is happening. Cool, but not an issue. This set of equations are the extreme points. Now, what we did is that we identified that x plus y multiplied by x squared minus xy plus y squared is equal to 0. Correct? So, uh, this becomes 0 when x plus y is equal to 0. Right? The other term can be equal to 0. We will come to that later. But let's first identify what happens when x plus y is equal to 0. When x plus y is equal to 0, then y will be equal to negative x. Correct? Since this happens, since this is the case, we will substitute y is equal to negative x in any of the equations. Let's say in the equation 1, right? Now, the equation 1, if you remember, it was 4x cubed minus 4x plus 4y is equal to 0. That was equation 1. If you forget, I'll show it here, right? So the first line 4x cubed minus 4x plus 4y is equal to 0. We have substituted y is equal to, we are planning to substitute y is equal to negative x in this equation. Okay, let's do that. So the first term remains, actually, we can cancel 4 from the entire equation. So that will give us a very nice looking equation, which is x cubed minus x plus y is equal to 0. So instead of y, we shall replace y by negative x, right? So minus x over here is equal to 0. And that shall give us x cubed minus twice x is equal to 0, right? And again, what we'll do is that we'll do some factorization here. Factorization would look like this: x multiplied by x squared minus 2 is equal to 0. So a little bit more of factorization can be done. What is the factorization? We can use again, there is an identity we had learned, that a squared minus b squared is same as a minus b times a plus b. And we'll take a as x and b as square root of 2. And we can write this as x minus square root of 2 multiplied by x plus the square root of 2 is equal to 0. Okay. Our aim is to identify what are the pairs of values of x, y, right? Okay. So this happens, when the expression x multiplied by x minus square root of 2, x plus square root of 2 equal to 0 happens when x equal to 0. That is one case. The other case is x minus square root of 2 is equal to 0. The third case is x plus square root of 2 is equal to 0. So the second case is basically x equal to square root of 2, right? And the third case is essentially x is equal to negative of square root of 2. Now, now you know that we had little while back seen that y is equal to negative x, right? Now let's substitute the values of x in this particular expression uh, in all of these three cases, and let's find out the values of y, right? So the first case, y will be equal to negative of 0, which is same as 0, right? And in the second case, y will be the negative of square root of 2. And in the third case, y will be the negative of root 2, which is positive root 2. Right? So from here, we are going to obtain the extreme points, right? We'll get this extreme points. The extreme points as 0 comma 0, right? And then square root 2 comma negative square root 2 and negative square root 2 comma square root 2. So these are the three extreme points we have obtained from this equation. Now let's find out what are the values of R, S, and T. Right? We'll find out what is the value of R, S, and T at each of these extreme points. But before that, we need to find out what fxx is, right? So the value of R, the expression for R or fxx with respect to x partially, just once. So dou by dou x and dou f by dou x was 4x cubed minus 4x plus 4y, right? So this will give us again, we'll jump the steps over 4y, which will become 0 because y is a constant when we find out the partial derivative with respect to x. So we have found known, and that is same as 4x cubed minus 4x plus 4y, right? That is dou f by dou y. And when we differentiate this partially with respect to y, the first term becomes 0, right? And the second term also becomes equal to 0. The final term has 4y, and when we differentiate that with respect to y, it becomes 4, right? So the value of s is equal to 4. I'll pause here for a second. What we are doing is we are taking the second derivatives. I'm not explicitly writing down the uh, the expressions like I've done in the first derivatives, but I think it's easy enough to convince yourself that this is the variable. T is the expression. T or Fyy, that is equal to dou by dou y of dou f by dou y. Second order. The first order is inside the bracket. The second order is what happens outside the bracket. But we have already found out what dou f by dou y is. So dou f by dou y would be 4y cube plus 4y minus plus 4x. My bad. Plus 4x minus 4y. Okay, now here, if you notice carefully, the first term has got a y. So then that is a variable of ours in this particular problem, in this particular partial differentiation. So 4 is a constant that comes outside, and y cube becomes 3y square. So 4 multiplied by 3y square gives us 12y square. The second term has no y in it, so it's a constant. Differentiation of a constant is 0. Doesn't matter whether there is a plus or minus. It just gets vanished. Then we have got 4y. 4 is a constant, and differentiation of y with respect to y partially is 1. So 4 multiplied 1 is 4. And there is a negative in front. So minus 4 is the value which we write here, the part of the expression. So what we got here is we got r as equal to 12x squared minus 4. We got s as equal to 4 and t as equal to 12y squared minus 4. Now what we'll do is that at each of the extreme values, extreme points, we will find out what is the value of r, s and t, and so the aim is to find out whether our point is a maximum or minimum or saddle point, or like the test, more tests are required. So the first column, yeah, someone wants to say something. Is that enough? Complete screenshot. Okay. Uh, from where do you want screenshots? I'll share this document with you. Yeah, yeah, yeah. Yeah. So that's the reason I have like put up this beautiful document. The watermark. I've changed the watermark is because I want to share this document with you. But as of now, I hope you have understood that how the fxx value is this, how the fxy value has come this way, and how fyy values have come this way. Right now, now we have nearly reached the end of the problem. Right, we now will find out what happens with each of the extreme values. Right, so we will make one column for the extreme value, the second column for the value of r, the third column we will make a table, right? The third column will be for the value of s, the fourth column will be value of t, and maybe a fifth column, a small short thin column for whether r is greater than 0, rs minus t square, rt minus s square, one column for that, so five columns. The sixth column for if r is greater than 0 or less than 0, and a seventh column for the final thing. So let's put a column, a table over here. So 7 rows, 7 columns, and oops, yeah, I think, yeah, we'll put a table over here, right? So 7 columns and 4 rows. Let's put this column, right? Okay, okay, let's resize the table a little bit. Okay, here we are trying to have a table which is going to give are following the algorithm to find out the type of the extreme point is the maximum, which extreme point is the minimum, which extreme point is a saddle point. Are there multiple? We'll write down the name of the extreme point, some value of x, comma, some value of y. We will calculate using the second, third, and fourth column. Now, if this RT minus S is greater than 0, if this if r is greater than 0 or less than 0, in this case we will say whether it is a maxima or minima. When rt minus s square, this extreme point is a 0 comma 0, right? At 0 comma 0 the will be equal to 0, because rt is 16 minus s squared is 4 square, that is 16, so that is equal to 0. More tests required, comma negative square root of 2. So the value of x is, so this is 20. S is 4. 4 minus 4 is 2, is greater than 0. Wow. So we should go to the next column and see here, right? R is greater than 0. So this minimum value. Okay. Now let's move on to the last. There is an x12 x squared. So x is negative square root of 2. X squared is 2. 2 multiplied by 12 is 20, is 12 multiplied by y square minus 4, right? So y is again square root of 2, y square is 2, 12 multiplied by 2 is 24. And here again r is greater than 0. We get another minimum point here. And that's how this problem has been solved. The partial derivation works there. Now, in partial derivative, in the chapter of partial derivative, you have to use the chain rule a lot. Okay, so a little revision of what chain rule is. You know, the chain rule. The chain rule. Mm, so, I'm going to use a lot of cartoon characters over here. All right. So, I want to use like derivatives as such, the total derivatives, but partial derivatives to explain you how things are working. Right. So let's say that we want to find the derivative of a function f with respect to a variable x. Okay. But this function f, so given function f is has uh, has two variables, right? And these variables are, let's say, what do we say? Uh, mm, U and V, U and V. Okay, so the cartoon characters are U and V. So this U and V, they themselves are, like kind of, uh, they themselves are kind of functions of U and X and Y. Okay, we are not so what is happening is that we are trying to identify we're trying to differentiate the function f with respect to x, but the function f does not have x in itself, right? For example you can for example um, we have got a function f uh, where x if the function f is of x by y and y by x, right? So this is the function, right? So this is the function. We want to find out what is, given this function, we want to find out what is dou f by dou x, right? So we need to find out a particular method to do this, right? We need to find out a method to do this. How do we find out the partial derivative in these cases? That is the that is the question that we have in our mind, right? So in order to do this, one method is to use the chain rule, right? The chain rule goes as follows. So what we can do is we can identify dou f by dou u multiplied by dou u by dou x plus dou f by dou v, right, multiplied by dou v by dou x. This is one method we can use, right? And this method is actually very powerful method, and we give this method the name of what we call um, the total derivative, right? So like we can work on it, and we can first find out the derivative of the function with respect to the first variable u, and then find out how the derivative of u changes, how u changes with respect to x, and similarly for the other variable v. And similarly, if we want to find out dou f by dou y, right? So function f, the y is like it's trapped inside here. So if you look carefully, the y is here in the denominator and in the numerator in the function. So finding out dou f by dou y would be a little challenging. But thanks to the chain rule and the rule of total derivative, we can find that out very easily in the following way. So we will consider x by y as, we'll consider x by y as u. We'll consider y by x as equal to v, right? And we will use the chain rule, dou f by dou u multiplied by dou u by dou x plus dou f by dou v multiplied by dou v by dou y. My bad. This is y over here. This is dou u by dou y. Okay, so this is dou u by dou y. Make sense, guys? Is it fine with you? Do you understand this one? Are you connected on the call? Okay, okay, fantastic, fantastic. So let's try to solve a problem, right? And try to, like get understand this completely, right? So there is a problem which says as follows, which says that uh, if uh, if u is equal to f of x minus y minus z minus x, right? Then show that dou u by dou x plus dou u by dou y plus dou u by dou z is equal to 0, right? So this is what like we have to prove. Hmm? Okay. Now what we'll do is we will use our method, right? We'll use our particular method to solve this particular problem. Whatever method we had discussed a little while back, right? What was the method? The solution was as follows. We'll say let P is equal to x minus y, Q is equal to y minus x, and R is equal to z minus x, y minus z, sorry. Is this convincing for you? Why are we doing this? We are just changing the variables, right? So that we don't need to basically we can't find the derivative dou u by dou x, for example, because if you look at the function, x is like completely intertwined with other variables, and there is a new variable there that we can see. Correct? So, what we'll do is that we will use the rule of total probability, which is the chain rule, same thing. Dou u by dou x will be equal to dou u by dou p multiplied by dou p by dou x plus dou u by dou q multiplied by dou q by dou x plus dou u by dou r multiplied by dou r by dou x. Okay, so it is dou u dou p dou x into dou u dou q dou x plus dou u dou r dou x, right? So it's very simple. It's very easy to remember. The only thing that you have to remember is, you see the p over here is the same p over here. The q over here is the same as q over here. The r over here is same as the r over here. And all of these have to be taken into consideration. There's a p here, there's a q here, there's a r here, right? All these artificial variables that have been created have to be used. Okay. All right. So let's proceed to solve this problem, right? So u by dou p, dou u by dou q, dou u by dou r. We can't find the values of this, right? These are unknowns. These are unknowns. So these unknowns, you leave them as it is. Whereas you can find out what dou p by dou x is, right? See, p is x minus y, correct? So since p is x minus y, since p is there, so dou q by dou x is equal to 0. There's no x there. Nowhere x is there in q. So dou q by dou x is simply equal to 0. Okay. Finally, dou u, dou r by dou x, right? In R, there is z minus x. Z is going to be equal to 0. But minus x will leave minus 1, which is equal to negative 1. And that's how you can see that the last row says that dou p is equal, dou p dou x is 1, dou q dou x is 0, dou r dou x is negative 1. And we'll substitute these three values in the second row. The second row, again, let's repeat it. The second row is a result of total derivatives. Right to the second row, and we will get the first equation here as dou u dou x is equal to dou u dou p minus dou u dou r. Similarly, now we'll go quickly, right? So we'll find out dou u by dou y. Dou u by dou y is again total derivatives dou u by dou p. See, we have got three new artificial variables. So for each of these variables, we have to do the same thing. What are we doing? We are differentiating the given function with respect to the new artificial variable dou u by dou q multiplied by we are differentiating the new variable with respect to the variable in question. So dou q dou y, and the last one will be dou u dou r multiplied by dou r dou y. Now we'll find out again what is dou p dou y, right? So p is x minus y. So x will become 0, y will become 1. There is a minus in between. 0 minus 1 is negative 1, right? Then we have got dou q by dou y, right? So dou q by dou y, again, this will give us y is, so q, mind it, q is y minus z. So we'll get 1 from y, minus is there, and then z will give us 0 because z is a constant when partially partial derivation is done on with respect to y. Z is a constant, so that will become 0. So it will become 1 minus 0, which is 1. And finally, dou r by dou y, r is equal to z minus x. There is no y at all. The entire thing is a constant. So we'll get a 0 over here. I will substitute these three values in the topmost row that you can see, line that you can see. So dou u by dou y will be equal to dou u by dou p multiplied by dou p dou y. Dou p dou y is negative 1. So this becomes minus dou u by dou p plus then dou u by dou q is multiplied by dou q by dou y. The dou q by dou y is 1. So it will become dou u by dou q. And then plus dou r by dou y is 0. So the last entire term is going to be 0. And that will give us the second equation. We get the second equation over there. Now, let's identify, let's use the total probability rule to find out what dou u by dou z is, right? Similarly, what are the artificial variables? The artificial variables are p, q, and r. Each of these artificial variables, we will have one term. This term derives from the chain rule and contributes to the total derivative we are writing right now. Okay, that's the concept. So the method is as follows. We'll write dou u by dou p multiplied by dou p by dou z plus dou u by dou q multiplied by dou q by dou z, right? And plus dou u by dou r multiplied by dou r by dou z. Fantastic. And once we have got this expression, we'll try to find out certain values. You see that P, Q, R are, we have assumed P, Q, and R, and they are expressions of X, Y, and Z, correct? So what we'll do, we'll find out dou P by dou Z, right? P is X minus Y, which does not have Z in it, and hence the entire thing is a constant. So dou p by dou z is 0. Secondly, uh, dou q by dou z would require us to take the partial derivative of q, which is y minus z, right? So, but then you see we are taking the partial derivative with respect to z, so y is going to be a constant, which on differentiation will give us 0. So y minus z will become 0 minus partial derivative of z with respect to z is 1. So it is 0 minus 1, that is negative 1. And finally, dou q, not dou q, pardon, dou r by dou z, right? That will be equal to 1 because r is equal to z minus x, and z will give us will give us 1 minus x will give us 0. So 1 minus 0. So dou r by dou z is equal to 1. And now finally we'll substitute all these three values in the first row that you can see, right? And we'll get dou u by dou z is equal to dou u by dou p multiplied dou p by dou z is 0. So this entire term is 0. Then dou q by dou z is negative 1. So we'll write minus dou u by dou q, right? And then plus dou r by dou z is 1. 1 multiplied by any number is that number itself. So that number is dou u by dou r. And this happens to be, my friends, the third equation. Correct? Now, let's summarize everything and we will get our proof, right? So, you see that in the question, so let's add all these equations, right? So, adding the equations 1, 2, and 3, we add all of these three equations, 1, 2, and 3. What do we get? We get on the left hand side dou u by dou x plus dou u by dou y plus dou u by dou z is equal to dou u. Let's write down dou u. Oops, yeah, what's happening? Dou u. Oops, my bad. Something. Yeah, yeah, okay. So what was that? Dou u by dou p minus dou u by dou r, right? Okay, okay, yes. Dou u by dou p minus dou u by dou r. Correct? Plus dou u by dou y. What was q? Okay, all right. Okay, looks like my system is not liking me doing this entire sum, but I'll do it. Minus dou u by dou p plus dou u by dou q, right? Okay, plus the final equation, the equation 3, okay, the equation 3, the equation 3 is dou u by dou z is minus dou u by dou q plus dou u by dou r, right? So this is minus dou u by dou q plus dou u by dou r. And ladies and gentlemen, we have got we got 0, hence proved. So this is how we can solve these kind of problems. Okay, see, I'll tell you, these problems are a little lengthy, right? But they are quite satisfying to solve, right? So, like for example, one more problem which can be done, there are lots of problems which can be done in a very similar way, right? For example, there could be a problem like this. Let's say u is equal to f of let's say twice x minus thrice y, and then thrice y minus 4 times z, and then 4 times z minus twice x, right? If this is if if u is this, then uh, then uh, we can write down half dou u by dou x plus 1 by 3 dou u by dou y plus 1 by 4 times dou u by dou z is equal to 0, right? So this is true. Then again, um, there are a few more sums like this which I would want you guys to really understand and do it on your own. I am always there to help you out. You can send the solutions over to me, right? So, for example, let's say x by z, f of x by z, f of y by z, right? Then find the value of x ux plus y uy plus z uz, right? So this might be one more model question that I would probably give you, and maybe one more problem that I would love that you would understand and do very nicely. This I think this problem was there in your assignment as well. We will solve this problem sometime later because we have got this 2 weeks of time. We just opened up. So if z is equal to e to the power ax plus by and f ax minus by, right? Then then what happens is the um, b times zx, right? Zx plus a times zy, right, is basically equal to 2abz, right? So even this relation holds true. Actually, for the last problem, there's a small hint that I would want to give you, right? So you just consider p as equal to ax plus by and q as equal to ax minus by. So that will help you solve the problem very easily. That is one method of doing. The other method of doing the second problem is by using a chain rule, right? By directly using the chain rule. Uh, so in the chain rule, there is a product chain rule and the product rule. So Zx, right? Zx is dou by dou x of e to the power ax plus by f of ax minus by, right? So what we can do is we can have we can actually what do I say? Look at differentiation of uv is same as u multiplied by the differentiation of v plus the differentiation of u multiplied by v. Correct? That's the product rule. So similarly, we can do it this way, do it that way here. So dou x of f of ax minus by plus plus dou by dou x of e power ax plus b, the chain rule, and you have to do is that let's take the derivative here. F power ax plus by, that comes first, and I'm just giving you a sketch of the proof. I'm not solving the problem completely, right? And then we have dou by dou x. Help you out with this a little bit more. So this will become e to the power ax plus by multiplied by f dash of ax minus by multiplied by, see here that this differentiation gives us a, just a, right? Because ax, the differentiation of ax is a, and the partial derivative of by is 0 because it is with respect to x, while any other variable, any other term, any other symbol is a constant, right? Plus plus e power ax plus by, and a differentiation of ax plus by is again a multiplied by f of ax plus by here, right? So if we write this down a little bit more nicely, what we get is e power ax plus by, and f dash, there is a dash here, f dash ax minus by, and the a, let's write on the a in front, right? So a in the front, plus there's an a which will bring in front, and notice that e power ax plus by multiply f of ax minus by, right? So this term over here is same as z, so we can directly write z over here, right? And that is zx. This entire thing is zx. This entire thing is zx, right? uh, and our z was, I think, yeah, the z was e power ax plus by, f of ax minus by. So we have to multiply b zx by b, right? That's what we have to do. So we multiply that and keep it aside, and basically we'll find out zy also very similarly. And when you find out zy, you'll find a minus symbol jumping around, at somewhere. And I want you to complete this problem and complete this. First, you complete this, then you move on to the other problems. And in the meantime, if you have got any issues, please do let me know uh, later. I think most of the video has been up, is being streamed live on YouTube. So maybe because of technical issues, some parts of the videos may not be recorded, but the gist of it, you can, it's good to go, right? This document is a little helpful for people who are trying to understand the basics, and a good revision can also happen. Okay, all right. So I'll end the live stream on YouTube right now. If you have any issues, please feel free to speak up now. This is the time.